This is Tim Albright with AVNation with AVNation Special, taking a look, quite frankly, at how to choose the right speaker. Now, in the industry, there are all sorts of different types of speakers. You have ceiling speakers, you have surface mounted, you have line array, you have all sorts of stuff. But with us to talk about that is a couple dear friends from AtlasIED. First and foremost, Graham Hendry. Welcome, sir.
Hello, Tim. How are you?
I am fine, and I'm going to enjoy the next half an hour listening to you and your lovely accent. Ivan Schwartz is also here with us from AtlasIED. Welcome, sir.
Thank you.
I'm going to start with this with a very, very simple question, and I know it's a simple question. But Graham, overarching, you're looking at a space, you're designing a space, whether that's a classroom, it is a banquet hall, it is a performance space. How do you choose the right speaker for that space?
Good question. There's lots of choices out there. Look at the application, first of all. Because you've seen it in a magazine or someone's recommended it to you, you might want to do a little bit of research yourself. Then you want to hit the books at the end of the day. What is the application? That's the overriding thing. Is it for BGM? Is it for speech? Is it for both? Make it effective. Make it work. Choose the right specifications. Do your research. Don't choose it because it's the latest shiny thing that someone's recommended to you. There is a lot of choice out there. So delve in at least a little bit further than the latest advert you've seen. There's a lot of information out there. There's a lot of specifications. There's a lot of, the biggest thing between a hi-fi loudspeaker and a speaker that's using commercial audio are the amount of assets that come along with it. From measurement data, simulation data, measurements. Have a good look. It's worth spending a little bit of time researching.
I have the same question, but something that Graham brought up there is not just do your research, but do the measurements. What sort of measurements? If I'm an IT manager and I'm working together with a trusted partner, what do I need to make sure that they're measuring? What do I need to make sure that they are looking at and considering as we're working together to make sure that we pick the right loudspeaker?
Obvious things like frequency response. I mean, it is this primarily a speech application where you want more of a tailored speech response as a multi-purpose application. Do you expect to have really high impact music presentation and speech, or just really high impact music? And so, all these variables obviously have to do with not only frequency response, but also what the desired maximum SPL is. How much sound pressure level am I looking to get? Is this a very even distributed system? Is it something just mounted at the front of a room and has to only cover 20, 30 feet, or 200 or 300 feet? So
the size of the space as well.
Yeah, size of space is huge. And of course, importantly, to narrow things down is the physical aspect of how can we mount these loudspeakers? Are we talking about a 12-foot tile bridge ceiling? So we're probably looking at a distributed system with in-ceiling loudspeakers. Is it a 30-foot ceiling, and we need to look at pendants, or perhaps some type of column array or digitally steered column array? And so a lot of different variables to kind of narrow it down into the proverbial ballpark, and then start looking at different options, different specifications for the particular application you're looking for.
Graham, I've been brought up a couple of different terms there that I want to make sure that we pause and identify here. First of all, when you guys talk about, when integrators talk about frequency response, what exactly is that? What does that mean?
Having a flat frequency response is what our ears are. Listening to the audio bandwidth, let's just say 20 hertz to 20 kilohertz is the standard sort of rule of thumb. You want a flat frequency response. You don't want holes in the response. But more importantly, you don't want holes in that response both off-axis and off-axis in the listening plane. I see a lot of loudspeaker specifications that don't carry a lot of, directivity data. You look at a specified directivity or coverage angle. You dig a bit deeper. You want to look at that over the frequency spectrum and not just at one frequency. So there's a lot of things to consider in that aspect.
So on the frequency response, you have humans when we're born. Typically, we hear between 20,000 and 20,000 hertz. You're saying on a frequency response on a speaker, we don't want that to have any holes or dropouts between that 20,000 and that 20 and 20,000. Is that what you're saying?
In an ideal world, smaller speakers produce less low frequency. You enhance that with sub-bass, etc. Again, depends on the application, but inherently, a flat frequency response is a good starting point. But that's within the specified area of coverage, not just when your head's on axis with a loudspeaker.
But it's the entire.
90% of the audience isn't exactly on axis, and if you're just looking at a 1 watt 1 meter on axis, it doesn't tell you a lot. Consider polars, beam width plots, other aspects like that, and we can get into modelling later on in this conversation as well.
And we will. Ivan, you also mentioned SPL, that sound pressure level, but what from a space standpoint, whether that is a conference room or it's a banquet hall, what should be the maximum loudness? What should be the maximum SPL of a space?
In a lot of applications, you're looking at the level above any ambient noise level. Now, if it's a presentation space or something, that's easy. And, I don't want to necessarily drift off into public address and things like that. But certainly there are cases where you have higher ambient noise levels than others. And an example of that might even be like a K through 12 classroom, where you're, trying to get up and above, let's say, people who aren't necessarily going to quiet down as much and be listening to what you're trying to present. Additionally, it's just kind of, I use the term impact, but if it's a ballroom, are you attempting to do DJ type level events, or is it just a general purpose system? A lot of times in general purpose installs, this isn't an issue, but, something I've run into before is, for example, music playback in band rooms, whether it be in high schools or colleges. And, obviously you want very wide frequency response, as Graham mentioned. You want to naturally reproduce it, flat frequency response, evenly cover the room. But then in that application, it's going to be a lot higher sound pressure level desired than just a general purpose reinforcement system in, say, a lecture hall or something like that. And it's not just the maximum continuous or peak SPL, it's also the coverage. Do you have pretty much, give or take, plus or minus, let's call it 2 or 3 dB, the same level from front to back in the room, so that everyone is getting essentially the same experience.
Graham, one of the things about these both frequency response, SPL, loudness of the space, loudness of the speakers in the space, rather, all of these things can be factored in, including the acoustics of the space, to impact the intelligibility. How do you make sure that you have, quite frankly, good intelligibility? And first of all, I guess I should ask you to define what is intelligibility in a speaker system.
Intelligibility is the ratio of reflections in the room. Let's start with intelligibility is the result of intelligibility is the room and the sound source. It's about the room being devoid of interfering reflections. You want the direct sound and less of the reflected sound. To put it simply, now the science behind it and the applying that isn't quite as easy. Anyone can hang a loudspeaker and turn it up, but it takes a bit of education and experience to design a system that's intelligible. If the music sounds good, it's not necessarily going to be intelligible at the end of the day. So intelligibility is all about ratios, and you've got to start with a decent acoustic space. There are loudspeakers like digital beam steering that can interact less with the room, more than a point source loudspeaker. But that's where you've got to start choosing loudspeakers for the application. So it's hard to fix a bad room. Starting point. Some rooms are better than others. It can be more expensive to treat a room than choose a loudspeaker, with a high price tag, like digital beam steering. But at the end of the day, it might, it's a question of economics as well. It may be better to choose that higher price tag loudspeaker than, grossly remediate a room with drapes and, expensive, acoustic treatment. Simply put, it's more of the direct sound and less of the reflected sound in the room. But, hit the books, and there are people out there that are very good at it. Engage. If you've got a difficult space, it's hard to go back and fix it later after you've made the mistake. Hire help, engage a consultant if you have to. Most definitely. They're worth their weight in gold sometimes.
Well, Ivan, if somebody does they're looking at their space, and I'm going to kind of walk you through a couple of different options here. When you're looking at either an existing space, right, which you can physically walk into versus a brand new construction, what should an IT or an AV manager do? To Graham's point, is it hiring the consultant? Is it leaning more on the integrator, or is it working with both to say, get our space to a good place where we can then start talking about, some sort of loudspeaker decisions?
Yeah, I think more complex spaces, especially more complex architecturally, particularly spaces where aesthetics are important. So think about like a corporate atrium, where you're not going to start hanging acoustic panels all over the place or significantly changing it. You might do that in something like a lecture hall. Churches are even like that. The difference between a cathedral, which again, aesthetically, it's unlikely you're going to start putting up huge absorptive panels and diffusers and such, versus a more modern facility. But especially in those cases, I think a consultant's probably the best bet, because you're going to have multidisciplinary people there. They have pure acoustics people that can work with the system designers as well and come up with a total solution. I'm not saying there aren't integrators that do that, but in general, for a more complex space, and especially one that is, let's call it, aesthetically challenging, and that you're not allowed to make significant physical changes to it, that you're probably best off looking at a consulting firm that covers both acoustics and AV system design.
Graham, we were talking about coverage patterns. We're talking about plotting those out. There are certainly reports that folks can create. Talk for a second about I guess the best way to read those coverage patterns, and what folks should be looking for when they get either a consultant-driven proposal, an RFP back from an integrator. What should they be looking for with those coverage patterns?
Let's talk about the tools available. Okay. Maybe first of all, there are simple ones. A lot of manufacturers have their own little wizards for coverage and heat maps. And generally, they're dealing only with the direct sound fields. So they're at least giving you a good handle on getting adequate coverage, at the various octave bands and broadband, etc. But that does not take into account the interaction with the room itself. There are wizards out there available from AFMG, EAD's address for ceiling speakers, EAD's focus for point source and line sources. But that's only dealing with the direct field. It's not going to give you, an intelligibility figure. So things like, again, EAD's 5, we support that with GLLs. We'll, as a manufacturer, also help on that side, but you have to be using our product. That's the deal. So yeah, there's tools out there that are more resolute than others, basically, and you'll find that, I don't know, everyone's an expert when they're pulling out maybe their heat maps of the direct field, and they've then designed a perfect sound system. It's not giving you any handle on how intelligible it will be. I can't even say intelligible. That's the So yeah, there's a lot of design aids out there, but you got to know how to use them.
Okay, so once you get that report, again, whether that's in a consultant or it's a reply back from an integrator, how am I reading that? Like let's say it's a heat map, and it shows me, some hot spots in some areas that are louder than others, and some areas that aren't as loud. Like when I'm looking at the best way to put this, I guess, is a heat map. What am I looking for to assess whether or not this is a good speaker design or a good speaker?
Good point. And again, a lot of these wizards will look at maybe just broadband coverage. Look at the very least, look at each octave band. You may have good coverage at 500 hertz, 1 kilohertz, but the loudspeaker may beam or narrow at higher frequencies, where you expect it to do, say, 60 degrees. Maybe at that higher frequency, it's only achieving 30 degrees. It may be uneven. So at least interpret and look at the octave bands. It may have great coverage at one frequency, but not at another.
Yeah,
and that's what the heat map. That's what the heat map will show you. That's relatively easy to interpret. But just dig in a little deeper.
Yeah, I mean, if you have just one heat map printed out, or you're sent a graphic or something, I mean, the first thing you have to do, look at it, is it broadband? Is it at a specific frequency? And then start to investigate more from there. Ideally, you have a number of heat maps at a number of different frequencies. As Graham mentioned, at least octave bands, and particularly octave bands where loudspeakers tend to be more directional. So if we're talking about, you get an EAD's address report, for example, look at it definitely above 1,000 hertz. They're all going to be very similar below 1,000 hertz in terms of an in-ceiling type of loudspeaker. But where things really start to change significantly is where you're getting above crossover point to that high frequency device, and also the transition point between the low frequency and high frequency device. There's often anomalies in the crossover area. So, ideally you get a report and actually have the software. Of course, things like EAD's address and EAD's focus are free. So just get the file sent to you and start digging into it. And as Graham mentioned, look at different frequencies, and also just keep in mind, it's an obvious thing, but keep in mind where there's going to be people and where there aren't. Because a lot of times you'll look at a heat map and it looks kind of odd, but then you realize, oh, well, this is an area we're not covering, or there's some physical thing there, and we're just looking at a reflected ceiling band.
That's actually a really good point. And that's something that some folks may not realize is it's a cost saving measure, but it's also, the fact that you don't have to spend money in an area where there's not going to be anyone listening, right?
Yeah, that's a good point.
And having the wherewithal and the kind of the presence of mind through the design phase, they go, okay, look, there's nobody in X, Y, or Z, or you know what, it's, I don't know, a janitor's closet, and I couldn't care less whether or not the janitor has background music or whatever. So, Graham, I want to get into something and talk about some specific areas, not just that Atlas has done, but from your guys' perspective and your experience. Two of the main categories, I guess, of speakers, and one is certainly ceiling mounted speakers, right? These are the speakers that go in ceilings and typically drop ceilings. You do have pendant speakers that drop from the ceilings, but pretty much you're talking about top down, right? The speakers are above you and they point, and the audio comes out of those. The other one would be surface mounted, and those can be line arrays, they can be point source or whatever, but they are on the wall somewhere, and they are pointed towards the audience where the people are. From your perspective, when should someone use a ceiling speaker, and when should someone use more of a directional speaker from the front or the side?
Good question. Again, depends on the space. Ceiling speakers are generally, used in distributed systems.
Okay.
Architectural constraints will be involved in that decision as well. But hanging a point source speaker or something else, generally, you may want to be trying to maybe localize on an aspect of the sound system. That could be a presenter, it could be a display. Sound, unfortunately, is a slow medium.
How define that for me?
You've got your cognitive abilities and psychological abilities, and if you're not concentrating on the presenter and the sound's coming from another direction, that can be quite fatiguing over time.
Yeah.
So localizing the sound to wherever the sound's supposed to be coming from. Unfortunately, sound travels way slower than light does. So it generally has to be emanating from that same point in space. But again, that choice is very application driven as well.
Yeah, particularly if you look at the space too, because sometimes surface mount and ceiling mount is purely a form factor difference.
That's true, and that's something. Sorry to butt in there, but just before I forget about it, it's something that we've been concentrating on. Lots of loudspeaker formats, surface mounts, pendants, ceiling speakers, use different transducer arrangements. A lot of manufacturers' surface mounts can be discrete, separate woofer and tweeter. It can be a coax in the ceiling speaker. Very recently, we've been, with one particular range, our high-end Atlas and Fine range, we use the same transducer, whether it's in in the ceiling or in the surface or in a pendant. As you transition between rooms, you may be using different formats in different areas, but you want that same sound signature and voicing as you transition, through the room,
and also from room to room, right? Especially
a hotel's a great a great example of that. You could have surface mounts outside, in the foyer area. You could have ceiling speakers in the bar. You could have, as you're moving around, it's nice to have that consistency.
And more and more you see either very high ceilings where you have to bring something down that might be a pendant, it might be a surface mount on all thread or something like that. And concrete ceilings, which, are quite common. I mean, they were extremely common probably 5 decades ago, and they seem to be coming back a lot. And you just don't have a place to recess a device. It definitely is going to be mounted either on some structure like unistrut or something, but very often to the concrete itself. So there, essentially, it's a ceiling loudspeaker, but the form factor is a enclosure that you'll physically see rather than just the grill.
Yeah. Guys, as we wrap up here, Graham, you mentioned, there are several different types of wizards out there, depending on the manufacturer. Specifically, though, for AtlasIED, when you're working with an IT folks or an AV manager who's working with a trusted partner of yours, how do you guys help this process? How do you assist somebody as they're asking the same very question that I asked to start with this? How do I pick the right speaker for my space? How is Atlas able to help and assist in that process?
It's a simple consultation, basically. They'll make contact. We actually have a team of design assist people. It could be a simple factory layout. It could be something way more complex. It could be a traditional church where they're looking for specific intelligibility. They will contact us through the website or directly if it's a personal relationship. Feel free to contact us directly. But we'll basically take the more resolute information we're given, the more resolute the design and help that we can give. Sometimes someone will hand you a simple floor plan on a PDF and ask you for a full-blown design. If you can get a hold of Revit, AutoCAD drawings of the room, if we can get details of the surfaces, we can input the surface coefficients, the absorption coefficients of the room. We can do a lot more. So it can be simple as a cookie cutter design for the purposes of, budgeting, or it can be way more resolute than that. But we're here to help. We're very approachable.
Ivan, if somebody's reaching out to you guys, what sort of questions? If you say, obviously Graham mentioned, the design of the room. Mm-hmm. What sort of questions, though, are you going to come back and ask kind of a back and forth with both the owner of the space, but also with the integrator? What do you need to know, and how are you guys going to dig into that?
Yeah, it's really clarifying a lot of what we talked about at the beginning of this, which was, what's the application? Is it a speech-only system? There's a lot of times the person has this thing in their mind of what they want, and they're not particularly great at communicating that. Oh, I need a sound system. And that can take a lot of forms. Is it a factory and you need paging horns? Is it, like I said, a band room at a school where you want a very wide bandwidth natural sounding system? So, we need to know some really basic things like that. And again, things like, what type of sound pressure level are you looking for? The early parts of it, we can make some assumptions, but a lot of times we have to ask a lot of questions to really narrow down what they're looking to do. And of course, that gets even more convoluted. If it's a multi-purpose space, they're trying to do a lot of different things. So we end up, asking quite a few questions. Sometimes the customer knows exactly what they want. I mean, we do this with consultants all the time and with integrators all the time. But basically, it's loudspeaker selection and application. We're really just trying to help them figure out what loudspeakers we have that can best fit this and how they can be applied in that space. And that might go, as Graham mentioned, all the way to full ease modeling. And because we need to, in a very tough space with high reverb times, be able to predict STI. The only way to do that is with a very accurate model with a lot of information. But if we just want to know, can you cover this large space with even coverage with an overhead distributed system, can do that as well too. So it's really a matter of knowing what the customer is looking for and being able to work with the people that we're working directly with, the consultants or the integrator, on figuring out the best solution for that.
All right. Really quickly, how long does typically this process take?
We've got, pretty well resourced. It depends who you're asking.
I'm asking you, Graham.
Okay, I'm trying to be a little bit agnostic here, We've got some really good people, and we can turn things around surprisingly fast. A matter of days. Some manufacturers will quote you a couple of weeks, maybe, and that's fair enough. It depends on the resource, but we're quite agile on that front, and we, it's about relationship building at the end of the day as well. Atlas is definitely trying to raise the bar from the source to the loudspeaker. We will supply the entire ecosystem in a lot of applications, but have a discussion with us. We don't bite.
All right, very good, gentlemen. Thank you so much, Graham Hendry from AtlasIED. Thank you, sir. How do people connect with you, and how do they connect with AtlasIED?
AtlasIED, as it says, .com. You can go to the website. I'm on LinkedIn. Graham.Hendry at AtlasIED.com. Drop me a line. We'll get right back to you.
All right, good, very good. Ivan Schwartz, how do people connect with you?
Ivan.Schwartz at AtlasIED.com, and also very active on LinkedIn as well. So please feel free to contact me directly through either resource.
You should be more active, Ivan, on LinkedIn. It's the new Facebook.
Oh my Lord! Don't do that to it. Don't do that to it.
Post dog photos and photos of what I'm eating.
All right. Thank you both so much. For us, for AVNation, go by our website, AVNation.tv. That's AVNation.tv. You'll find this program and a host of others. All that and more at AVNation.tv. That's AVNation.tv.
The network for the AV industry.
What are you listening to?
This
is AV.
This
is AVNation.
This is AVNation.